Hi students, in this lecture I am going to discuss problems. Let us see first one. See the question given. Electric field and magnetic field in a region are given by E bar equal to E naught J cap and B bar equal to B naught J cap. So given both the fields along same direction, okay, along positive y-axis. A particle of specific charge alpha. Specific charge means charge per unit mass means Q by M is projected from origin with velocity v naught I cap. So velocity vector is now normal to these two vectors, right? Determine the velocity of the particle as a function of time. Find the position of the particle as a function of time. Find the y-coordinate of the particle when it crosses the y-axis for the nth time. So given both the fields which are uniform along positive y-axis. Velocity, it is v naught I cap, right, from origin. Let us see how to start the problem. So first write down the given data. So electric field vector E bar, that is E naught, it is E naught J cap. Next, magnetic field vector B bar, it is B naught J cap. And velocity vector is now along positive x-axis, V naught I cap. So we have to find velocity as a function of time. Next, it's a position vector as a function of time. Right. So now see how to start it. Let us consider, first of all, only the effect of magnetic field. Assume there is no electric field, only magnetic field. Then see what happens. Velocity is now along positive x-axis. Magnetic field is along y-axis. Means between these two vectors, angle is now 90. So when angle is 90, it follows circular path. It is uniform circular motion. Okay. So now what I am saying is, let us consider only magnetic field, right? Then path must be uniform circular motion. That means speed is a constant. And if you observe in which direction force acts initially, if you observe force F bar equal to Q into V bar cross V bar. Suppose here nothing is mentioned, take charge as a positive. Velocity is along I cap. So I cap cross, I am focusing only direction part. I cap across B bar along y-axis. So I cap across J cap. It is now K cap. Means at the time of projection, force is along positive z-axis. So from this we can decide in which plane motion is confined. To which plane motion is confined. Okay. So from this we can say that a motion is confined to xz plane. I will draw a diagram here. So because at the starting force is along positive z axis, that's why motion confined to xz plane. So it is, let us take this is now z axis and this is x axis because velocity vector is along x axis and force is along z axis at origin. So motion is confined to xz plane. So velocity vector is along x axis. Now path will be, it follows now circular path. It is uniform circular motion. Okay. Now see what we can say. This is a part of a circle. Let us draw one normal for this velocity vector. For this velocity vector, take one normal. Take normal for velocity vector. See angle made by the velocity vector with x-axis. So take it as now theta. Okay. So here one condition is that magnetic force does no work. Okay. By magnetic force, no work is done. That means its speed does not change. That means since motion confined to xz plane, we can write Vx square plus Vz square should be equal to V naught square. Okay. Now velocity is having two components along x-axis and along z-axis, right? If this angle is theta, this angle is also theta, right? Then see what we can write. Vx is, it is always V naught. Speed is not changing. It is now V naught cos theta. I am writing here. V bar equal to V naught. V naught cos theta I cap. V naught cos theta I cap plus V naught sin theta k cap. See carefully. Motion is confined to xz plane. So velocity vector is having two components along x and along z. So v naught cos theta I cap, v naught sin theta k cap, right? And here what about theta? So since speed is a constant, see here we can say omega also constant. So we have learned that time period equal to 2 pi em by big, right? Or from this frequency equal to bq by 2 pi m, right? Frequency. Now coming to angular frequency, that is 2 pi f, which is equal to bq by m. 2 pi gets cancelled, bq by m. And in the question it is given specific charge, means a charge per unit mass, right? This is now equal to what? B by alpha. It is given B naught, right? So take here B naught. This is B naught. Okay. That means omega value B naught by alpha. That means now theta value, how much means theta equal to omega t. That is now B naught by alpha into t. Okay. So V naught given value cos theta, in the place of theta writing omega t. Omega value V naught by alpha into, sorry, omega value V naught by alpha into t. That is now theta. Means we got now velocity vector, right, as a function of time. Now focus. how to get position vector. So coming to position vector, see what we can do here. Take one line parallel to x-axis. So here x coordinate will be, if this is now radius, where r equal to m v naught by bq, right? Since between b bar and v bar angle is 90, it follows now circular path. Its radius is given by m v naught by bq. Now in this triangle, we can see this right angle triangle. What we can say, sine theta equal to x by r, means I can say position vector. Position vector. Let us call this as r naught radius to avoid confusion between position vector and radius. Okay. Now r bar equal to it is xi cap plus z k cap, because motion is confined to xz plane. So it has only x and z coordinates. And coming to here x value, it is r sine theta. X value is r sine theta. So r sine theta I cap plus in the place of z. See carefully. This value is now this value is r cos theta. This is now location of the particle. For that, this is now z coordinate. You can see from here. Or let us say this is A, this is B, and this is C. Okay. B is now location of the particle, and C corresponds to its z coordinate. And we can see here AC. AC is equal to R naught. This is what? R naught, right? Radius. R naught. This is R naught. Sorry, not AC, it is AO. Let me correct it. Right. In the diagram, AO, that is R naught. We want to calculate OC. OC means R naught minus R naught cos theta, right? Total values R naught radius. From that subtract now R naught cos theta. So Z value R naught into 1 minus cos theta k cap. So we know what is theta, right? Theta is known. So we got now velocity vector and position vector as a function of time. But in the problem, we are given electric field also, which is along magnetic field. So now path will be, it is helical with increasing pitch, because along the field, velocities keep on increasing. Is a pointer. See how to calculate pitch. Pitch will be equal to, how to calculate. I think here we have to mention in which time interval, okay? Because along y-axis, velocity is not a constant. Velocity is not a constant, okay? So first we have to observe, because of this, where change is coming. Coming to velocity vector. Velocity vector, this remains same. For this, we have to add one more component. See here what I am doing. Velocity vector v naught cos theta I cap remains same. Coming to along y-axis. Along y-axis. Initially no velocity, right? Initially no velocity. And along y-axis, because of this electric field, acceleration is constant. So we can write velocity equal to along y-axis. Acceleration is q e naught by m. We can say y component of acceleration because of the electric field. That is now acceleration into t. This is y component of velocity j cap. Okay. Plus remaining one v naught sine theta k cap. So that is the only change. So here what I'm saying is a path is helical with increasing pitch. Okay. Because speed is increasing, or you can say component of velocity along the magnetic field is keep on increasing because of electric field vector. Okay, right. Coming to position vector r bar coming to x, no change. R naught sine theta I cap plus along y-axis displacement. Along y-axis, initially velocity component is 0. I am repeating. Along y-axis, initially velocity component was 0. So question is just like starts from rest along y-axis. So displacement will be half a t square, half a value q e naught by m, half a t square j cap plus remaining as usual v naught sine theta k cap. So r naught sine theta I cap plus this is half a t square. This is t square, okay? Let me correct once to avoid confusion. That is t square. T square, right? The only change is here having y component of velocity, here having y component of displacement, right? So here conclusion is both fields along same direction, velocity normal to fields, then path will be it is helical with increasing pitch. Okay. Next here having one more question, that is find y coordinate. Right? Asking find y coordinate after n revolutions. Then see what happens. What is now time period of revolution? 2 pi m by bq, right? He's asking the y coordinate. Y coordinate means what we have to focus. Half a t square. So y coordinate is equal to half a value q e naught by m, half a t square. He is asking after n revolutions. One revolution means time taken 2 pi m by bq. N revolutions means n into t. N into t value 2 pi m upon bq. Half a t square. Now simplify the remaining part. See remaining part what we are going to get. 2 square, that is a 4, and this is 2 here, remaining 2. Right? 2 pi square. N is there, n square. Right? Next, what else? 2 pi square n square. We are having E naught, right? Which is a constant E naught. C1's numerator 4 by 2, 2 pi square n square, pi square n square, E naught. Okay. Next, coming to here. So here having m square, and this is one m is there, remaining is m is there, q, this is q square by q, right? It is now b naught square, this is b naught, okay? And in the place of q by m, what is it? It is a q by m, that is alpha. In the place of this, I can write here alpha. Alpha stands for q by m, right? So finally, y coordinate is 2 pi square n square e naught by alpha b naught square. Okay. So here we have to focus one key point. Whenever it is a helical path, axis of that helix will be along the magnetic field vector. So here magnetic field is along y-axis, right? That means it is a touching. The particle touches y-axis after every one revolution. Is a point clear? So we got here velocity vector. Where is that? Yes, velocity vector. This is position vector, right? So main thing, while starting, we have taken that first only effect of magnetic field. Then finally, we have taken effect of electric field, means where change comes in position vector, in velocity vector. So that makes the analysis more easy and simple, right? I hope you got that clarity.